All right, on to the arithmetic section. First up, Clarissa will create her summer reading list by randomly choosing 4 books from the 10 books approved for the summer reading. She will list the books in the order in which they are chosen. How many different lists are possible? Okay, so she is choosing 4 books out of 10. So this is a pretty simple problem to start with. Her first option, she's going to have 10 books, and then she'll have 9 books to choose from, and then 8, and then 7. So we're just going to multiply all these numbers together. 10 times 9 is 90, 8 times 7 is 56, and 90 times 56 is 5,040. So our answer here is going to be answer choice D. If n is a positive integer and the product of all the integers from 1 to n inclusive is divisible by 990, what is the least possible value of n? Okay, so we have some division from 1 times 2 times 3, all the way to n, and it needs to divide evenly into 990. The output needs to be a whole number. All right. So how can we assure ourselves that we're going to have a whole number? Well, we need to look at the prime factorization of 990. Let's go out to the side and do that. So 990, that's 99 times 10. That is 11 times 9. 9 is 2 3s, 3 times 3, and 10 is 2 times 5. All right. So I'm going to replace this 990 with the prime factorization. And again, that's 2 times 3 times 3 times 5 times 11. So if all of these values cancel out by what's on top, then we know that whenever we divide it, we'll have a whole number. So what could be going up top? What could that be? Well, we know that we're going to have to cancel out this 11. So we're going to have to at least go to 11. So answer choice A, B, and C are not going to be possible. If we go up to 11, will we cancel everything else out? Well, of course, we'll have 1 times 2, the 2 will cancel, times 3, the 3 will cancel, times 4 times 5, oh, the 5 will cancel, times 6, oh, the other 3 will cancel, and then ... all the way up to 11, and finally the 11s will cancel. So what is the least possible value of n? The least possible value of n here will be answer choice D, 11. I do quickly want to point out that it's not always going to be the largest prime here. What if we had instead of 990, just as a quick bonus question, what if we just had a number like 16? Well, 16, its prime factorization is 2 times 2 times 2 times 2. So what would work here? Here, let's clear this up. So what would work here? Well, in our division, in our denominator rather, we have 2 times 2 times 2 times 2. And so up top, where would we go? We wouldn't stop at 2 because that just cancels out one of the 2's. We would have to keep going. Times 3 times 4. 4 will cancel with 2 of the 2's. And then times 5 and times 6. 6 will cancel with our last 2. And so this answer, if we are asked for 16, the smallest value for n would be 6. Okay, so I just want to clear the air there. Let's move forward. The probability that m will not occur is 0.8. The probability that event r will not occur is 0.6. If events m and r cannot both occur, which of the following is the probability that either event m or r will occur? So if we want to know the probability that m or r will occur, we're going to take the probability that m occurs and add it to the probability that r occurs, and then we're going to subtract the probability that they both occur, that m and r both occur. So what is the probability that m occurs? Well, we're told that it will not occur 0.8 of the time, so it will occur 0.2. Similarly, we can say r will occur 0.4. And then we're told in the question that m and r cannot both occur. So we're just going to subtract 0. So the probability that they both will, or that either will occur, is going to be this sum, which is 0.6. So our answer is choice C. Next question. The total cost for company X to produce a batch of tools is $10,000 plus $3 per tool. Each tool sells for $8. The gross profit earned from producing and selling these tools is the total income from the sales minus the total production cost. If a batch of 20,000 tools is produced and sold, then company X's gross profit per tool is what? Okay, so in this question, again, feel free to pause the video, solve it on your own. But for this question, we are looking for the gross profit per tool. Okay, so to find the gross profit per tool, of course, we need to know what our revenue is. And we're going to then subtract our cost in order to tell us our profit. So revenue minus cost is profit. And we want our profit per tool. So then we're going to take our profit, and we're going to divide it by 20,000 because we have 20,000 tools, okay? So what is our revenue? Well, if we have 20,000 tools and each sold for $8, then our revenue is 20,000 times 8, or 160,000. And here I'll write it in a different color. So we have 160,000. What's our cost? Well, we're told that our cost is $10,000 plus $3 per tool. So our cost is going to be $10,000 plus $3 per tool. So 3 times 20,000 is going to be 60,000. So our cost is in order 70,000. Whenever we add 10K and 60K, we'll get 70,000. So whenever we subtract the two, we see that our profit is going to be a whopping $90,000. Now, again, we're not done yet. We're asked for the gross profit per tool. So we're going to do $90,000, our total profit, divided by our $20,000. All these zeros cancel out. 9 over 2 is 4.5. So our answer here is choice C. Our profit per tool is $4.50. If Q is an odd number and the median of Q consecutive integers is 120, what is the largest of these integers? Okay, so we have, again, feel free to pause the video and solve these on your own. I'm just going to be jumping in and solving them for you guys so that you have a solution, but it's definitely recommended for you to have a paper and pencil out and solve these problems on your own. So we have some list. Okay? I'm just going to have 3 items in our list to make it simple, but there could be many more. And we're told that the median value is 120. So the median value is going to be 120. That's going to be the middle value. And we want to know if it says if Q is an odd number and the median of Q consecutive integers is 120, what is the largest of these integers? So in this little example I've made, what do we have? Well, our list is of 3 consecutive integers. So in this case, Q is set equal to 3. And we are asked for what is the largest of these integers. Well, in this case, if we have consecutive integers, our highest one, our largest would be 121. And of course, our lowest would be 119. So we don't have 121 as an answer because we don't know how long q is. You know, this could continue going out and out and out. However, you can always use your answer choices to help you. And so with this little example, I would just plug in 3 for q and see which one gives me an output of 121. Okay, for A, 3 minus 1 is 2, 2 over 2 is 1, and 1 plus 120 is 121. So this looks like this works. What about choice B? 3 over 2 is 1.5. That's not going to be an integer. Again, this won't be an integer. 3 over 2 is 1.5. For choice D, we have 3 plus 119. That's going to be 122 divided by 2. That's going to be way less than 121. In choice E, again, this won't be an integer, as 3 plus 120 is 123 divided by 2, way too small and not even an integer. So with this simple process, I'm able to see that our answer is choice A. If there are fewer than 8 zeros between the decimal point and the first non-zero digit of the decimal expansion of t over 1000 to the 4th power, which of the following numbers could be the value of t? 3, 5, 9, any of them? Would any of them work? Would only option 1 work, only option 2, only option 3, or both option 2 and 3? Okay. So feel free to pause the video to see if you can solve this one on your own. This one is a little bit tricky. So we need to think about what will the decimal version of t over 1000 to the 4th look like. Okay, well, if we expand this, so if we have t2 over 1000 to the 4th power, this is of course the same thing as t to the 4th over 1000 to the 4th. And what is 1000 to the 4th? Or more importantly, what will this look like as a decimal? Well, 1000 to the 4th is just going to be 1000 times 1000 times 1000 times 1000. And hopefully all you guys are familiar with the fact that if you multiply those together, you're just going to add all the zeros. So 1000 has 3 zeros. So if we multiply it by 1000, we're going to have another set of 3 zeros. And then by another 1000, we'll have another set of 3 zeros. And then by the 4th 1000, we'll have a 4th set of 3 zeros. So our denominator in this case looks like t to the 4th over this huge number. Let's go out to the side and think about, what if we just think about this simple fraction of 22 over 100. What does this look like as a decimal? Well, as a decimal, this is going to be 0.22 because this is read as 22 hundredths, okay? We're 22 out of 100, we have 22 hundredths, okay? What if we just had a 2? What's 2 out of 100 as a decimal? Well, that's going to be 0.02. This is 2 hundredths, right? Okay, all of this to say that whatever your numerator is will begin to fill your denominator from the back end, okay? So let's say t to the 4th. Well, let's start with 9, as 9 is our largest value. What is 9 to the 4th power? Well, of course, we have 9 times 9 is 81, and then we have 81 times 81, which is some value. Let's multiply that really quickly to get our answer. So we multiply these, and we get that 81 squared, or 9 to the 4th, is 6,561. So let's replace t to the 4th by 6561. Okay, so what is this going to look like as a decimal? Well, as a decimal, it's going to look like 0. How many zeros do we have? We have 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the 6561 is going to fill in these last 4 zeros. This will be 6, 5, 6, 1. And how many zeros are left here? That's 1, 2, 3, 4, 5, 6, 7, 8. That's 8 zeros. So we're told that if there are fewer than 8 zeros, we don't have fewer than 8 zeros here. We have 8. So choice 3, number 9, that doesn't even work. And so our answer is going to be A, none. Okay? Going to throw a bonus question in there for you guys. What would be the first integer or t rather, that would work? What would be the first integer t that would work, that would allow us to have 7 or fewer zeros? Well, we need to cover this place. We need to cover this place value. So whatever our integer is, whenever it's raised to the 4th power, it would need to be at least 10,000 in order to cover this 5th zero from the back end. Okay? And what do you know? But 10 to the 4th power is 10,000. So if 10 was an option, that would be a valid response. However, since 9 is the largest of our options and it does not make the mark, our answer is A, none. For each student in a certain class, a teacher adjusted the student's test score by using the formula y equals 0.8 times x plus 20, where x is the student's original grade, y is the student's adjusted grade, and if the standard deviation of the original test scores of the students in the class was 20, what is the standard deviation of the adjusted test scores of the students in the class? Okay, so we need to figure out how did the standard deviation change whenever we applied this formula to all of the grades in the class. So to first even answer this question, we need to be comfortable with standard deviation. So standard deviation is simply the average distance from the mean, and we need to understand how it's affected whenever we manipulate our list. So let's say our list is something like 10, 10, and 10. Now we know that this isn't the case because we're given that our original standard deviation is 20, but just hang in there. We need to first understand standard deviation. What would be the standard deviation if we were given this list of 10, 10, and 10? Or our standard deviation here would be 0. Okay, and that's just because they all have the same value. If you have a list where everything is the same value, then your standard deviation is going to be 0. Next, let's think of a list that has a standard deviation of 20 so we can manipulate it. Okay, well, we're taking test grades, so let's say someone got 100, someone aced it, got a perfect score, and then someone didn't do so well and they got a 60. So here we have a list of two things, 60 and 100, and it has a standard deviation of 20. And that's just because the mean, the average of these two values is going to be 80, and both 60 and 100 are a distance of 20 away from the mean. So here our standard deviation is 20. Okay? So I want to quickly point out that if you add or subtract consistently from your list, your standard deviation does not change. We're told here that our teacher is putting the grades through this function of 0.8x plus 20. Okay, well this 20 really has no bearing, and let me quickly show you. If we add 20 to both of these, we'll have 80 and we'll have 120. And while our mean did shift up, the spread of our values and the distance from the mean remained constant. The mean for this set is 100 and the distance is still 20. 80 is still 20 less than 100 and 120 is still 20 more than 100. Okay, so just adding or subtracting consistently across your values will not change your standard deviation. However, we also have this scale factor of a 0.8. Okay, this is a compression. Whenever you multiply your values by a number, they'll either get more spread out or they'll slim down, right? Think of a function. If you multiply it by a scale factor, it's going to stretch or compress. So what will happen to our original list whenever we multiply it by the 0.8? Okay, well, what is 80% of 60? We're going to have to subtract 12, and that's going to give us 48. Okay, and if we multiply 100 by 0.8, we're going to have 80. Again, you can go ahead and add the 20. It won't make a difference, but let's just do it for fun. So we have 68 and 100. So notice that our first value changed, but our second value didn't, just by the nature of what this function was. But however, our standard deviation will have changed here. The new mean for our list is what? Well, it's going to be 168 divided by 2, which is 84. And how far away are the values from our mean 84? Well, 68 is 16 away, and 100 is also 16 away. So our standard deviation for our new list is 16. I also just want to point out to you that you could have just taken your original standard deviation, 20, and multiplied it by this 0.8 value, and 80% of 20 is 16. So that would have been another way to get the answer, but I was trying to explain to you standard deviation and how it worked a little bit more. So if you got this one is a harder one, especially if you don't understand standard deviation. Let me know down in the comments below, and let's continue forward. So last year, 26 members of a certain club traveled to England, 26 members traveled to France, and 32 members traveled to Italy. Last year, no members of the club traveled to both England and France, and 6 members traveled to both England and Italy, and 11 members traveled to both France and Italy. How many members of the club traveled to at least one of these 3 countries last year? Okay, so this is definitely a Venn diagram problem. So let's draw in some circles. Try to make them consistent, but this circle tool is a little wonky sometimes, but that looks pretty good. Perfect. So I'm going to label these England, France, and Italy down here at the bottom. Okay, so what were we told? We're told that 26 members went to England. Okay, so that means out of all of England's circle, there's going to be 26. 26 members traveled to France. 32 members traveled to Italy. So this is all good info, but we can't fill in our circles yet. But here's this first bit. Last year, no members of the club traveled to both England and France. So we can put in some zeros. If no one traveled to both England and France, then this is a 0, and this would be a 0. Okay? If no one traveled to England and France, then no one traveled to England, France, and Italy. Okay? 6 members traveled to both England and Italy. England and Italy had 6 members. And 11 members traveled to both France and Italy. So this marking here will be 11. So now we can use our original info, we're told, in that 26 members traveled to England. Well, if 6 are here, that means this value must be 20. And if 26 members traveled to France, then similarly, we can say that this is 15, as 15 plus 11 is 26. And then we're told 32 members traveled to Italy. Therefore, this must be 15 as well, because 15 plus 11 plus 6 is 32. So lastly, all we need to do is figure out how many members of the club traveled to at least one of these countries last year. So we are going to add up all these individual values. 6 plus 11 is 17. 20 and then 15 and 15 makes 30. Add these all up and we get 67. So our answer is choice B. Fantastic. Onward. A store reported a total sales of $385 million for February of this year. If the total sales for the same month last year was $320 million, approximately what was the percent increase in sales? Okay, so last year it was $320 million, and this year it's $385 million. So that's going up by $65 million, okay? That's a plus $65 million. And we want to know approximately what was the percentage increase in sales. Okay, so if we're looking for the percentage increase, we're going to take 320 as our total, as our original, okay? So for our percentage, we're going to have 65 over 320, and we need to find this as a percentage. So something I'm quickly noticing, hopefully you guys are too, that 65 is awfully close to 64. And 64 over 320 would be what? Well, this would simplify down to 20%. Okay? This would simplify down to 20%. And so our answer, it does say approximately, our answer is going to be C, 20%. Fantastic. When positive integer x is divided by positive integer y, the remainder is 9. If x over y equals 96.12, what is the value of y? Okay, so this is a fun problem. Feel free to pause the video to see if you can solve it on your own. So for this problem, we need to understand the relationship the remainder has to the decimal that comes from a division that's not a whole number. Okay? And what do I mean by that? Well, let's take something simple. Let's say we have, 8 divided into 10. This is something simple. We would all know this to be 1, remainder 2. Another way to express this division would be 1 and 2/8, which simplifies, but we'll leave it as is. Or we could even write out the decimal, where 8 goes into 10 one time. You place your 8, you subtract, you place your decimal, you move down your 0, and then you continue this process until you have a full result of 1.25. And what I want you to pay attention to is the relationship between the 2/8 and the 0.25. Of course, they're equivalent. All of these are valid forms of our division. But I want you to notice that in our question, we're told that the remainder is 9. So if our remainder is 9 and y was in our denominator here, then we know that 9 over y is going to be equal to what? Well, it's going to be equal to 0.12, as 0.12 is the decimal part of our division. Just as 2/8 relates to the 0.25, 9 over y is going to relate to the 0.12. Now let's rewrite 0.12 as 12 over 100, just so we can make things a little simpler. And now we can just cross multiply to solve for y. Or you can notice that, hey, 9 or 12 to 9, that's 75%. And so 100 to y, we also need to do 75%. So y is equal to 75. So our answer here is choice B. What is the smallest integer n for which 25 to the n is greater than 5 to the 12th? Okay, so for this problem, we need to know about exponent rules. So whenever you're comparing exponents or values that have exponents, it's important to have the same base. So you need to know that and understand how to change 25 to the n to 5 squared to the nth power. Okay, this is the exact same thing, and it's important to do this because now it's much easier to compare 5 squared to the nth to 5 to the 12th. Okay, so to continue to rewrite this, we have 5 to the 2 times n is greater than 5 to the 12th. And since we have the same base, we can forget the base altogether and just write 2 to the n, or 2 times n rather, is greater than 12. And we need to figure out what value of n makes this statement true. If we're looking for the smallest integer, then that answer must be 7, as if we chose 6, we'd have 12 is greater than 12. This is strictly greater. This is not greater or equal to. This is strictly greater, and so we're going to choose 7 as our answer. If it was greater or equal, then we would choose 6, but since this is strictly greater, we're going to choose choice B, answer 7. 60% of the members of a study group are women, and 45% of these women are lawyers. If one member of the study group is to be selected at random, what is the probability that the member selected is a woman lawyer? Okay, so we have some group, and let's make things easy. Let's say our group has 100 people. Okay, and we're told that 60% are women. So that means we have 60 women. And we're also told that 45% of those women are lawyers. So of these 60 women, if 45% are lawyers, how many is that? Well, if half are lawyers, that would be 30, right? So it's going to be a little bit less than 30. And a little bit less than 30 is going to be choice C, 27%. Of course, you can do the full math. You can do the full math, and let's do that for fun. So if we want to know what 45% of 60 is, we can just multiply them. This cancels. The 6 cancels with part of the 10 to leave this as a 5 and this as a 3. The 45 cancels with the 5 to leave a 9, and 9 times 3 is 27. So this shows us that 45% of 60 is 27, and 27 out of our original 100 people is going to be 27%, answer choice C. Each year for 4 years, a farmer increased the number of trees in a certain orchard by 1/4 of the number of trees in the orchard of the preceding year. If all of the trees thrived and there were 6,250 trees in the orchard at the end of the 4-year period, how many trees were in the orchard at the beginning of the 4-year period? Okay, so we have some starting amount of trees. I'll use T for trees. Okay. And so in year 1, we have T trees. And then in year 2, what do we have? Well, we're going to have T times 5/4 because we increase the number of trees by 25% or by 1/4. So we still have the remaining, and then we have the 1/4 extra. And then in the next year, we're going to do this again. So we're going to have T times 5/4 times 5/4. And we're going to do this 2 more times for our 4-year period. Okay, so all in all, we're going to have T times 5 over 4 to the 4th power is going to be equal to our resulting 6,250 trees. Let's go ahead and clear this. We don't need this anymore. So what can we do? And also let's move this up. Let's move this up. Okay. So here all we need to do is solve for t. So what is 5 to the 4th? Well, 5 times 5 is 25, and 25 times 25 is 625. And then similarly, 4 to the 4th is 16 times 16, which is 256. And so we're left with t times 625 over 256 is equal to 6,250. Now we can multiply both sides by the reciprocal of this value. That's 256 over 625. And we'll multiply by the reciprocal in order for these to cancel out. 256 over 625. And now notice that 6,250 and 625, those cancel very nicely. This will cancel with this and leave 10 remaining. And so our result is that 2,560 is the number of trees in which we started with. So our answer here is choice D.